Imagine a universe where billions of galaxies are home to countless stars, each with the potential for planetary systems of their own. In this immense cosmic theater, the Earth is just a tiny stage. Given this almost inconceivable vastness, it seems logical to expect the universe to be filled with voices from extraterrestrial civilizations. But we looked up to the sky and found deafening silence. This perplexing contradiction is the heart of the Fermi Paradox, the fundamental question we will explore. With so many possibilities, where's everyone? This paradox, named after the Italian physicist Enrico Fermi, is a dichotomy that challenges our expectations and pushes us to question our understanding of the universe and our place in it. On our journey today, we will delve into the depths of this question, unpacking layers of science, speculation, and the immense puzzle that is our cosmos. Join us as we search for answers, or at least as we learn to ask the right questions. The Fermi paradox emerges from a collision between statistics and science, between what mathematics tells us about the likelihood of extraterrestrial life and the apparent absence of evidence for such life. It's a question that goes to the heart of astrobiology and the search for extraterrestrial intelligence. How can, in a universe with billions of galaxies, each containing billions of stars, many possibly with habitable planets, there be no detectable signs of intelligent life? This question, formulated in the midst of an informal conversation, has become one of the most intriguing and persistent in modern science. The formulation of the paradox forces us to consider several complex possibilities. Fermi and his colleagues toyed with the idea that if advanced civilizations existed, their technologies would allow them to colonize the galaxy in a relatively short time, geologically speaking. And yet, we do not see megastructures orbiting stars, nor do we receive communications at frequencies that would be logical for transgalactic use. Where are the imperfections in our logic or observations? The simplicity of Fermi's question is deceptive, as it opens the door to a series of potential explanations, ranging from technological limitations to laws of cosmic development that we do not yet understand. Maybe we are alone, maybe our search is flawed, or maybe, just maybe, we are not listening correctly. The Fermi paradox is not just one question, it is an invitation to discovery. When we probe the skies for signs of other civilizations, we use an imagined measure to understand their possible technological development, the Kardashev Scale. Designed by Soviet astrophysicist Nikolai Kardashev in the 1960s, this scale is a way of categorizing civilizations by the amount of energy they can use. A Type 1 civilization would dominate the energy of its planet, one of Type 2, that of its star, and a Type 3 civilization, the energy of your entire galaxy. But the question that remains is, what stage are we at, and what does that say about our ability to find others? Our own world still struggles to reach the level of a Type 1 civilization, efficiently managing the planet's resources without the risk of self-destruction. Meanwhile, the possibility of a Type 2 or 3 civilization seems distant but fascinating, suggesting a control of cosmic energy on a scale that defies our imagination. The Kardashev Scale allows us to dream of possible futures and better understand our position on the cosmic spectrum of technological evolution. This scale is more than a theoretical tool. It is a reflection of our ambitions and a guide to what we could one day become. If other civilizations have managed to advance beyond Type I, they may have overcome the barriers that currently limit us, including interstellar travel and communication across the vastness of space. She also suggests that if such a civilization exists, its presence should be evident through technological signals that we simply cannot ignore. At the heart of the scientific search for extraterrestrial life is the Drake equation, an attempt to estimate the number of civilizations in our galaxy with which we could potentially come into contact. From how many stars are born annually in the Milky Way to the fraction of planets that could support life, each term in the Drake equation is an open door for debate and discovery. Given the vastness of the universe and the promise of the Drake equation, why then is the cosmic silence so deafening? Many hypotheses attempt to explain this stillness, each offering a unique insight into the Fermi paradox. Some suggest that perhaps we are blind to intergalactic communication, limited by our technology and understanding. Others propose the idea that advanced civilizations can voluntarily isolate themselves, or that intelligent life is ephemeral, quickly succumbing to self-inflicted disasters or natural cataclysms. And there is still the unsettling possibility that we may be alone, the only voice in a universe of silence. Each hypothesis carries its own philosophical and scientific implications. If life is a rare phenomenon, what does that say about our responsibility as its only known representatives? If silence is the result of self-destruction, what lessons can we learn to avoid such a fate? The answers to these questions are crucial, as they guide us not only in our search for others, but also in our journey to understand and preserve our own existence. Finally, silence can be a message in itself, a cosmic sign to encourage our humility and aspiration. While some see silence as a sign of isolation, others see it as an invitation to reach for the stars with more determination. Perhaps the real question is not why the universe remains silent, but rather, how can we become so advanced that others can no longer ignore us? In our quest to resolve the Fermi Paradox, we came across the concept of the Great Filter, a theoretical hypothesis that suggests the existence of a critical stage, or several stages, in the evolutionary process of life, so insurmountable that they prevent practically all civilizations from reaching a state of technological advancement sufficient for space colonization. This filter could be in the past, suggesting that the emergence of life or the leap into complexity is extremely rare, or it could be in the future, implying that all advanced civilizations are destined to collapse before becoming intergalactic. If the Great Filter is behind us, we would be one of the rare life forms that manage to navigate this cosmic barrier, making us exceptional in the universe. On the other hand, if the filter is in front of us, it could serve as a grim reminder of the inherent limitations of intelligent life, and that perhaps there is a limit to technological survival and prosperity. The idea of the Great Filter not only proposes a solution to the Fermi Paradox, but also offers an existential perspective, inviting us to reflect on the fragile nature of life and the preciousness of our conscious existence. Ultimately, it encourages us to look inward and outward, pondering our role in the cosmos and the choices we make as a species capable of influencing our own evolutionary destiny. Among the various attempts to explain cosmic newness, the Zoom hypothesis stands out for its almost cinematic nature. She speculates that superior extraterrestrial civilizations may know of our existence, but choose not to interact with us directly, observing us from a distance as a kind of natural experiment or out of some cosmic ethic of non-interference. Perhaps we are living in a galactic reserve, protected or untouchable, while life out there flourishes in unimaginable complexity. This hypothesis confronts our perception of humanity's position in the universe. Are we the center of reserved attention or merely ignored inhabitants of a forgotten corner of the cosmos? The idea may seem discouraging, suggesting that we are still too primitive to come into contact, or encouraging, in that it indicates that other life forms may be actively preserving ours. If the zoo hypothesis comes close to reality, it evokes profound questions about autonomy, sovereignty, and interstellar ethics. What would be the nature and objectives of civilizations that opted for such a distancing policy? And what would it take for them to consider us ready for official contact? As we contemplate these questions, perhaps most important is to consider how we, as a species, choose to present ourselves to this cosmic audience. In the wake of the deafening silence of the cosmos comes the human effort to find those who may be calling across the dark expanse. Research projects and SETI, the search for extraterrestrial intelligence, represent the forefront of our unwavering desire to not only discover, but also to connect. Each project, each signal collected, each hour of observation brings us closer of a possible answer to the Fermi Paradox. Whether finding silence or a distant murmur of civilization, SETI research keeps the flame of curiosity burning, ensuring that if there's someone out there trying to communicate, we're listening. If you are as intrigued as we are about the Fermi Paradox, don't forget to like, share with friends, and subscribe for more mysteries of the universe.